So guys, welcome back. Day 5. Let's continue and try to smash out 2 problems. See where it takes us. I was actually looking at a few sliding window problems. So I think we're going to do a bit of that. I guess let's just do longest repeating character replacement, and then I guess we'll look at the question of the day, see what that is as well. Let's take a look. Count the number of fair pairs. Seems like a bit of a tougher problem. So I was right, 33.5. Alright, well, we'll come back to that one. Let's, oh geez. It's been a long day today, so let's take a look at this one. The longest repeating character placement. I think that one shouldn't be too hard. Longest repeating. Oh, no. Oh. Yeah, longest repeating character replacement. I think that's it. Longest repeating character replacement. Yep. Okay. Given a string S and integer k, you can choose any character of the string and change it to any of the uppercase English characters. You can perform this operation on most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. The longest repeating characters, which is 4, then Okay. Some more questions. We got no hints. Sucks. Well, we obviously know it's a sliding window problem, so I guess let's think about the way that we can do this. Well, we know it's a sliding window problem, so let's make our variables left. That'll be our pointer for the left, and then we got probably our max length. And then gotta think of what data structure we can use here. So damn. That's as you got AV. What's the best way to do this? Can we use a hash set, maybe? I'm trying to think. No, how can we use a hash set? We could add them to the hash set. If it's seen in the hash set, then right in range length S. I'm going to move our right window, but I'm trying to figure out how we're going to keep track of the letters. I don't know what the best way to do that would be, to be honest. Best way to keep track of longest repeating don't want to see the solution though. I really don't know what the best data structure would be to... I know how to do the sliding window to check everything, but I just don't know how we can remember every single other value. Check. Let's ask ChatGPT. We'll say, let's copy this. Ooh. No, we just want to copy it. Let's say Leetcode 424.longest repeating character replacement. What is the best data structure used to remember the characters while using sliding window technique? Oh jeez. Hash map. Okay. Well, I was on the right track. I said hash set. Hash E is equal to... I think that's how you do it. Okay, we want to use a hash map to keep track of the frequency of each character within the window. Maintain 2 pointers left and right to represent the window boundaries. Slide to the right pointer to expand the window and add each character's count to the hash map. Calculate the length of the window and use the frequency map to check the count of the most frequent character. You can determine if the current window length minus this frequency is within the number of replacements allowed, K. Slide the right pointer to expand the window. Okay. Man. Sorry, my mom's texting me. Sorry I don't talk much when I do this stuff. I think like I don't know about everyone else, but I think so incredibly slow. Like in my mind, like it's so hard for me to like visualize like the instructions that of how to solve a problem, and then to like actually put that into code is like really difficult for me. Like probably a lot more difficult than it is probably for the normal person. I just find it very tough. Increment value of hash map Python. Python. I can't even remember how to do this. What the fuck is this shit? Like. I get confused between hash map and hash set. Let's call it my dick. My dick. If that's right, not in my dick. And we can just increment by 1. Right? Else s right is equal to 1. Calculate the length of the window and use the frequency map to check the count of the most frequent character. You can determine if the current window length minus this frequency is within the number of replacements allowed. Okay. Well, I guess I'm not even using the sliding window yet. Let's do, and then we can loop through it for I in range like this. I'm thinking we use like a while loop here. I mean, this is. But how are we going to do this? We see a value, right? Count is equal to K. I'm gonna look at what ChatGPT says. Could you max underscore freak is equal to 0. So I should just continue within this for loop. Instead of using right in range this. So here they tell us to update the max freak, which would be the max freak should be max freak, and then let's start right. Oh shit. Oops. My underscore dick. After each iteration, you update the max freak. So then they pretty much, this is the difficult part, they just have an if statement here. Where they mess with the thing. So if right minus left plus 1 minus max freak is greater than k, reduce the count of the character at the left pointer. This is the part of the algorithm I don't really understand. If the window size minus the most frequent character count exceeds, if the window size. Okay, well our current window, right minus left plus 1. We have a plus 1 to make it, because we have an inclusive range. Minus left plus 1 is apparently, minus freak. Minus max freak is greater than k. Reduce the count of the character at the left pointer. That's right. Minus equal to 1. Oh, sorry, left. Using our left pointer. Then we left plus to 1. So we shift the left pointer to the right. And then we update our max length. Oh yeah, max length is equal to max underscore length. And then this is the maximum length of the window. Right minus left plus 1. Apparently, I think outside. Is it within the for loop? Okay, it is within the for loop. And we want to turn the max length. What I don't understand, so obviously I get this, we're looping through the array, right? That's the right in my, if we see it, if that's the right in my dick. If S right is in my dictionary, then we increment it by 1, else we make it equal to 1. And we update the max freak. If right minus left plus 1 minus the max freak window size from left to right minus the frequency exceeds the allowed replacements. Okay, yeah. Okay, I think I'm understanding a little bit. So we're calculating our max freak every single time. If right minus left plus 1, which is the window minus the max freak, is greater than k, so greater than k, which is the amount of positions that we can fill in, then we shift the left pointer by 1 to the right. Then we can keep track of our max length through that. Okay. What is going on here? Oh, that's fine. What do other people do? Like, bro, what is this, bro? Like, this looks like the most fucking difficult way to... This guy uses a hash set, so we could use a hash set if iron range length s. So it's equal to 1 plus hash set. That is a tough problem, man. I like to think about that. Like, it's a very tough problem. Hey, but we're grinding, man. We're getting better. We're getting better. 89 problem solved. You know, sometimes, like, I don't know, like, I've done 89 problems, man, and I've learned so much in the 89 problems I've done. You know, when I first started, like, even with my first problem, like, I could barely do an easy problem, you know, and, like, I had taken some computer science courses before, but, like, you know, just the way to, like, think about it is, like, was hard for me, you know? So it's like, I've come a long way already being 89 problems done, like, you know, sometimes it, you know, takes some help, but like you're just really learning all these different techniques to be able to solve these problems. So, you know, if you're struggling out there, man, just keep going, man. Just keep going. Don't feel like you're behind, man. Like, you look at other people on YouTube and stuff, like, bro, and they're like absolute bosses, bro. Like, they can do like anything in like 1 second, you know. So it's like, don't feel bad that you can't do that. Like, you're on your own path and just keep going, bro. Like, you know. So, all right, well, let's continue through. I did another one early today. Actually, I'm gonna go to it. This one, 5 hours ago. Let's just push this. There we go. Okay. I like this thing, man. Download this thing. Leetcode V3 or something. It's fine, man. Pushes it to your GitHub. Pretty cool. Alright, well, let's take a look at this one. This is probably going to be another tough one, man. It's got a 30% acceptance rate, so... Give it a 0 index array, integer array nums, the size and 2 inches lower and upper. Return the number of fair pairs. INJ is fair if 0 is less than or equal to I, is less than J, is less than N, and lower is less than N. This is a tough problem, man. I didn't even... Bro, these are some tough problems, man. Fuck. Sometimes the problem just comes to you like that. You know, I'm like, oh, I know how to do this. Like, and it's like, sometimes it's like, I don't even know where to begin. Like, level 3 over 6. There are 6 fair pairs. 0, 3. 0, 4, 0, 5, 1, 3, 1, 4, 1, 5. How is this a fair pair? Nums I plus nums J. 2, 3, 5. And our lower is 11. Like, bro, what? Oh. I mean, bro, like, what? Check out and sort the array in ascending order. For each number in the array, keep track of the smallest and largest number in the array that can form a pair with this number. I don't really understand the question. With nums of size n and 2 inches lower and upper, return the number of fair pairs. But what is a pair? I don't know. Like, I understand 4, 5, 4, 5, 6. You know, it fits in between. But how is 2 and 3 a fair pair? The low is 11, the upper is 11. Like, bro, what? Like, it doesn't fit this. Right? Or am I tripping? Like, 11, 5, 11. Like, what? Can you explain 2, 5, 6, 3 dot? I think we're going to start with a root force solution. I in range length nums for j in range length nums. Nums j is greater than law, and that's just this. If and is equal equals nums j. If ends is greater than lower, and ends is less than upper, count is equal to 0. Let's add count plus or equal 1. And we can how did we get 10? I wonder if we can do like if lower I wonder if this is like if that's the way that you can do it, maybe. Why are we getting double the amount? Like what? Maybe we have to sort it first. That actually didn't make a difference. See what ChatGPT says. I wonder if we can just do like yeah, I wonder if this will work, bro. This is like such a math.floor. Oh shit. Before I use ChatGPT, return math.floor count over 2. Bro, I wonder if this will work. Like, put int out here or something. Bro, if this works. There's no way. There's no way. It's not going to accept it. No shot. Okay, well, let's see what's wrong. What is wrong with my solution? Okay, we forgot. Well, I forgot this. I has to be less than J. I think this should be correct. Well, let's get rid of this crap. Doesn't count. I don't know if it'll be too slow. I don't think it's going to pass all the test cases within the time limit, to be honest. Oh my god, what am I missing? Oh. I think I'm missing that. I don't think it's going to pass everything within the time limit. To be honest. I don't even think we need it. Oh. What? You passed 29 out of 54 test cases. Yeah. All zero, 0, 0, and the output is 0. Computer died. No. Okay. Try to think here. I don't even think it needs to be sorted anymore. This is just wasting more time. Get rid of all this. For J, yeah. Time I've exceeded. Like, bro, what is this test case, bro? Like, what? Alright, so...
Okay, so focus up. Let's get after it.
Okay. So I guess we're gonna have to optimize this. So it says here we can use a 2-pointer approach, sort the array, use 2 pointers and count the amount of valid pairs. Alright, well let's do that. We can nums2 is equal to sorted nums. There we go, sorted. And then get rid of this double nested for loop. Keep this stuff. Okay. Okay. Can loop through this. Like dumps to. Trying to think. Sorry. Oh my gosh. While nums2 right plus fuck, dude, this is so hard to think. Count is equal to 0. Two sort of nums left is equal for left and range length nums2. Guess this should be right. Because we're gonna have our left while nums2 right. Left is greater than. Right. I'm lost. I'm officially lost. I was thinking of a way, but I don't think that's a two-pointer solution. Like, fuck it, I'm gonna finish it. For left. Left plus 1, while nums2 right plus nums2 left. No, you can't do it like this. Has to be right for right in length. Nums2. So apparently you can just do a nums dot sort. Didn't know that was a thing, but okay. Our left is equal to 0. Apparently have to do while left is less than right, and nums right plus nums left. Less than lower. Okay, we were close. Less than right and listening. And lower is nums left. That is upper. And we can add the count. I don't understand why the count is right minus left, but okay. Probably the left is meant to be in a loop or something. To be a while as well. Take a look. I'm lost.
Hello, welcome. Let's try to solve another.
Want something more clear? Count the number of f. What is this?
Hello, so today we are going to do problems from weekly contest 332. The second problem is count number of fair pairs. So what this problem says is we get an array of numbers of size n, and we have two integers, lower and upper, and we want to return the number or the count of fair pairs. And by fair pairs here, they mean that the sum of the elements is in the range lower to upper, right? And the indices needs to be different, of course, right? One of them smaller than the other. So for example, here in this array, the pairs that have validated that condition are 0 and 4, because the sum then is 4. 4 is between 3 and 6. And so these are 0, 1, 2, 3. This is this one. These are the indices, by the way. And then 0 and 4 also, that's a valid one. 0 and 5. 5 is between 3 and 6. 1 and 3, right? That's so basically 1 plus 4, which is 5, which is in the range. 1 plus 4, again, still 5 in the range. And then 1 plus 5, which is also 6. 6 is in the range because this range is closed, right? Like here and here, okay? So the total number of these pairs is 6. So pretty straightforward to visualize. Now in terms of constraint, the length of the array is 10 to the power of 5. The range itself is 10 to the power of 9, right? So this already tells you you can't try every pair of indices in the array, because that would be at least 10 to the power of 10, right? And so we need to find a better solution here. So let's see how we can solve it. So the first thing we need to think about is, let's sort the array, because what we are trying to do is find a sum of two elements, right, for I and j that are smaller than an upper value and smaller than lower value. So to be able to make any assessment on like moving pointers or anything, we need to sort. Okay? But if we think about sorting, there is one thing we need to think about, because the problem says we need I smaller than j, right? For if we take nums of I plus nums of j, right? But if we sort, we need to think about, does this impact this at all? Well, it doesn't, because if we take the sum of num at I plus num of j is actually equal to the sum of num at j plus nums of I. So whether I is smaller than j or I is bigger than j, it doesn't matter. We can just flip the order, right? And so this tells us that it doesn't matter which index is smaller than the other one. All that matters is that they shouldn't be the same index, right? You can't add the same the number from the same index. And that's logical, because we want two different numbers as a pair, right? And so sorting, this means that sorting won't actually impact anything, because as long as we don't take the same index twice. Okay, so we established that we can sort. Now, how do we approach getting the two numbers, counting the pairs where the sum is between upper and lower? So we need to think about something here. So I have an array here, right? Just a drawing of an array where these are, let's suppose that these elements here are those that have this condition valid, I and j, sum between upper and lower, okay? If we assume that, then we know that this portion here, right, it's all the pairs that have the sum smaller than or equal to upper, right? Because these here, the pairs here, are those that have the sum between upper and lower, right? And so these are all those that are smaller than or equal to upper, because they go up to the start. And these from this side here, these are those that have the sum smaller than lower, right? Because those that we have here are exactly bigger or equal to lower, right? And those here are smaller than or equal to upper, right? So that means basically that to find this here, we just need to find what are the number of pairs that are overall smaller than or equal to upper, and we need to find those that are strictly smaller than lower, and that will allow us to find the remaining portion, which is those that are strictly between lower and upper, right? That are exactly between lower and upper, right? Just simple array subtraction here, right? We have a bigger set, we subtract the smaller set, we get the remaining set, right? And why do we do this even? Because calculating this here is a lot easier than calculating this. Calculating this and this is a lot easier. It's just counting the pairs that have a sum that is smaller or equal than a single value. And this here is just counting the pairs that are smaller than a single value, right? And so if we sort of say that p of smaller than or equal to upper, so this would be just the number of pairs that is smaller or equal to upper, and this is the number of pairs that is smaller than lower, then this is exactly our answer that we are looking for. This is the pairs that are between lower, that have the sum between lower and upper, right? And so if we sort of, since this one takes just the smaller equal to lower constraint, let's try to make this match the same format. And so we can just make this be smaller than upper plus 1, right? This is the exact same thing. So this here is the exact same thing as doing this, because smaller than if you have something smaller or equal to upper, it's the same as it's smaller than the next value, right? Because here we have only whole integer values, right? And so the problem now reduces to just finding this here, right? So how do we do it? Well, we just want the count of pairs of numbers that have the sum smaller than upper plus 1, and we want the count of pairs that have the sum smaller than lower. So we need just one function that calculates the number of pairs with sum smaller than some value x, right? That's what we want, and that will, if we have this function, we can calculate both this one and this one. And so for that, we can actually use 2 pointers to count this, to count the number of
Just
pairs
gets the
with
point, man.
sum smaller than x. And we can apply this only because we sorted the array. So how does that work? So let's say we have this array here. We can just have our pointer here and here, right? And as long as the sum is bigger than the x value, we need to reduce the sum to have a chance for it to be smaller than x, right? And so we just reduce j we move it to the left, right? If the sum is still bigger than x, we move it to the left. So we keep moving it to the left until the sum is smaller than x. And the first time we find that the sum is smaller than x, that means basically that, so let's say for example here at 5, now we find that the sum is smaller than x. Well, that means that this entire portion is pairs that have sum smaller than x, because taking the biggest value, right? Taking the by the way, just to clarify what I mean here, it just means that pairing 0 with this one would be smaller than x, with this one would be smaller than x, with this one would be smaller than x, and with this one would be smaller than x, right? Okay, and then we move I and try again with the rest, okay? I hope that was clear. So let me just clarify again. So if we first we fix I and j here, and we want to just find the j's that pair with this 0 so that the sum is smaller than x. So we start out here, we find that 0 plus 7 is not smaller than x, that have the sum between lower and upper range. Okay, so review. So what we need is first to define a function that has for pairs, that counts the number of pairs with sum less than x value, right? That's the function that we are going to use. And what we said is first we need to sort the array, and then we could use this function here to count those smaller than upper plus 1. So that will give us all those smaller equal to upper, and similar one here, smaller than lower, and this will give us those with the sum exactly between upper and lower. So this is what we need to return. And now we just need to define this function. So we need 2 pointers, one at each of them at the far left and far right. And while the 2 pointers have not met, we want to do while they have not met and the sum is bigger or equal to x. That means it's bigger than x, right, or equal to x. So to make it smaller, to get to smaller than x, we want to move it j to the right to have a chance of having the sum smaller. Okay? So we do j with 1, and now we need, of course, the overall count. So let's call that count equal to 0, and that's what we want to return at the end. And so here, what do we need to add? Well, we said it's just j minus I, right? Those are those between pairs with I and let's call this k, such that k is basically in the range I plus 1 to j, right? So those are the pairs that we count here. And then we want to increment I plus 1, okay? And that should be it. So if we run this, looks good, and it passes test cases, right? We want to the range I it's j it's called and then we want to increment I plus 1.
Her explanation wasn't the best. Explanation was not the best. Create some pointers. J is equal to arms minus 1. Y is less than J. Y is less than J and this is definitely probably wrong, but sum is less than lower. Okay, get this one. I plus is equal to 1. Also, if sum is greater than upper, we want to move J backwards. Else, it's in the middle. Account. What I don't understand is that just why they do this. Why this? Oh, it's the range. We're adding those range of values. Oh, okay. Oh, bro, I feel like I just gotta like understand the problem better. Like, jeez. Still not getting the correct solution, but I'm not really 100% sure why. Jesus. Bro, what the fuck is this, bro? Jesus, dude. Sorry. Man. Dude, I don't know. Screw this, bro. I'm just gonna... use a function, man. This is so stupid. How does that sort? Alright. Count font, plus 1 minus count font. Well, define count font with X. We have I is equal to 0, j is equal to length of thumbs minus 1. I is less than j. I is less than j. And nums I j greater than or equal to x. So equal to let's see if I can understand this better. Go away, dude. Oh my gosh. Alright, I think we're gonna call it. To wrap my head around that was tough. I don't understand how these people come up with solutions like this, bro. Like, crazy. Like, I mean, obviously I could do the brute force one, but fucking takes way too much time. Bisect underscore right. What the hell is going on here? Alright. Thank you for watching. We're gonna call it. See you guys tomorrow.